Hello and welcome to Back to Coding. In the previous video we saw how to use functions in Kotlin. In this video we will see Kotlin's null safety. What is null? Null is nothing but an absence of a value. It means no value exists. Let's say you have a field known as qualification. Qualification can be graduate, postgraduate, PhD or anything. But consider a scenario where a person is illiterate and doesn't have any qualification. Then according to you, in such scenario, what do you think should be the value for the field qualification? Of course the value can be an empty string, but don't you think it should be a nullable type? And the absence of a value is known as a sentinel value as well. It is much better to have a special type which represents the absence of a value. There can be two scenarios. First, when a value exists, and second, when a value doesn't exist. As mentioned earlier, null is nothing but the absence of a value, and Kotlin has nullable types that handles the possibility that a value could be null. At a higher level, a Kotlin type fits in either of the two, nullable type and non-nullable type. Kotlin's type system is aimed at eliminating null pointer exception from code, also known as the $1 billion mistake. If you are familiar with Java or some similar type of language, then you might have come across the NPE, that is null pointer exception error, several times, which is the most common pitfall in many programming languages. So Kotlin handles it with nullability. Nullability is a type where Kotlin compiler itself doesn't allow any types to have a value of null during compilation itself. For example, so as you can see here, Kotlin doesn't allow null to be assigned during compilation itself. And if we want a nullable to be set, then we need to append a question mark at the end of the type. As you can see here, now it allows null to be set. And if we print it, then we can see null as the output. Adding a question mark changes the type from string to string with a question mark, int to int with a question mark, and so on. So we need to handle it very carefully. For example, if we access the length of both of these variables, then let's see what happens. As you can see here, we are getting an error. Only safe or non-null asserted calls are allowed here. But we still need to access that property, right? There's a way of doing that. Explicitly checking if a variable is null. So similar to Java, we can handle it with if-else blocks. Now here again, for every variable we need to check for null using if-else blocks, which leads to plenty of code. There's a better second approach to this, which is safe calls. The safe call, which is question mark with a dot, runs the line only when the value is not null, else it prints null. So in our previous example, the lengths for the thought and another thought variables will only be printed if it is not null, else null will be printed. Let's see the magic. As you can see here, so many lines were replaced with just a single call, which is a safe call. And if we remove null from the variable thought, then it prints out the length of the thought variable. Here it now prints 43 as the length, and for another thought variable, it prints null as expected. The third option is the not null assertion operator, which converts any value to a non-null type and throws an exception if the value is null. Note that this operator should be used only when you are sure that the variable's value is not going to be null. Else, it leads to an NP, that is null pointer error exception. Let's see it practically. As you can see here, for the variable thought, it has properly printed the value as 43. But for another thought variable, it has thrown NPE exception since another thought's value is null. Casting is the process of making a variable behave as a variable of another type. For example, we make an int to behave as a double, and so casting may sometimes lead to class cast exception when the object is not of the target type. In such scenarios, we use question mark operator for preventing class cast exception. So let's get back to our editor. Here, as you can see that for thought variable, it has successfully printed the value. And for int type variable, we have used safe cast, which is returning null since a string cannot be casted into an int. Also, as you can see here, the editor smartly shows us this cast can never succeed here itself. And if we remove our safe cast, then it shows type mismatch. The Elvis operator can be used to set a default value instead of getting null as the result. This is how it is used. Let's see it practically. As you can see here, when we call the print function first time, it properly prints the length. But when we call it second time, it is giving us the result as -1. That is, it is giving us the default value, which is -1 in this case. So it is equivalent to this. Let function runs only when the value of the variable is non-null, else it doesn't execute the set of code. This is how it is used. For example, so here as you can see, only first time the thought is printed, whereas when the thought is initialized with the value null, then it simply doesn't execute the set of code. That's it for this video. I hope you enjoyed it. Please give it a like and comment down your thoughts below. Don't forget to check my other videos which can be helpful to you.